Okay, and we're back, and we're looking at starting with number 74. All right, if you're presented with a matrix and you're asked to give the order and identify the given element of the matrix, first of all, we want to tackle the order. That's rows by columns. So on 74, I've got 2 rows and I have 4 columns. So the order is 2 by 4. And they also want me to find the element that's in row 1, column 2. So row 1, column 2, that would be 8. So element A subscript 1, 2 is 8. All right, so the order here is I have 1, 2, 3, 4 rows times, and then start counting down the columns. It looks like it's 5 columns. And we're supposed to identify the element that's in 3rd row, 4th column. Looks like 12. All right, and finally, the last page. And I think I can do most of the work, if not all of it, on this sheet. It'll be kind of sloppy, but my worked out solutions are more nice, neat, and organized, and you can consult those if need be. Okay, you could write on this on your own handout sheet, or you can, write on your notebook paper. All right, 76. We're given 2 matrices, and we're asked to find the sum, A plus B, and we can only add 2 matrices if we have the same dimension or same order, and they're both 2 by 2, so we can add. And so the sum is just going to be adding corresponding elements. So -9 plus 6 is -3. 1 plus 2 is 3. 2 plus 1 is 3. And 5 plus 1 is 6. All right, in 77, we're asked to subtract 2 matrices, and they do have the same order, so we are able to subtract. And we just subtract corresponding elements. So -1 minus 7, 4 minus 2, 0 minus 17, etc. Looks like -6 there. All right, before I go to 78 and 79, though, I feel like we're missing a multiplication problem here, and I think it might be a good idea to remind ourselves about how we multiplied matrices. So what I'm going to do is I'm going to make a little adjustment. On 76, I'm going to say, what if it asked me to multiply, find AB? So if I'm asked to find AB, you might remember that to multiply, we have to make sure that we have the same columns and rows, same columns in the first matrix and rows in the second. So the order here is 2 by 2, and the order of the B matrix is also 2 by 2. Meaning if these two are the same, equivalent, these columns and rows, then our answer matrix is going to be a 2 by 2. So just for the sake of reviewing multiplying matrices, I want to go ahead and multiply A and B here. So I know my answer matrix is going to be a 2 by 2. So what we did is we built the structure of that 2 by 2, and we did label each of these blanks. So this blank is in row 1, column 1, row 1, column 2, etc. Row 2, column 1, and row 2, column 2. And that helped remind us that we choose only rows from the first matrix and only columns from the second matrix. So row 1, column 1. And so we have 2 numbers within each of these rows and columns, so we multiply. So -54 plus the next product, -54 plus 1 is -53. And then row 1, column 2, so we did -18 plus 1 is -17. And then you drop down and you pick up row 2 and go back and multiply it by each of the columns. So 12 plus 5 is 17. And here we'd have 4 plus 5, which is 9. So you won't see that on my worked out solutions. I just noticed that there wasn't a multiplication of matrices, and I thought, well, that might be a good thing to review. All right, returning to look at 78 and 79. I'll leave those for you guys to do. We just did determinants of a 3 by 3 determinant, so these are simple compared to those. Okay, let's look at 80 and 81. Write the first 4 terms of the sequence whose general term is given. So we've got this little formula here. So we want 4 terms. So we just take turns letting n be 1, n be 2, all the way up to n equals 4. And I think I have enough room to where I'm going to just kind of come over here and say, okay, a sub 1. So if n is 1, n is 1 here. So that's going to be 2 times 1 minus 1. So do the parentheses first. 2 minus 1 is 1. 1 times 2 is 2. So the first term is 2. Okay, the second term. So a subscript 2. So I still have 2 times 2 minus 1. That's 4 minus 1 is 3. 3 times 2 is 6. A sub 3. 3 here, 3 here. 6 minus 1 is 5. 5 times 2 is 10. It appears to me that I'm increasing by 4, making this an arithmetic sequence with a common difference of 4, but I would probably go ahead and make certain that the next value is 14. So a sub 4. So, yep, it is. So here are the selection of the first 4 terms of the sequence that you would choose. All right, for 81, the first 4 terms. So let's see if we can do this maybe without all this work here. So a sub 1 is going to be 3/5 to the first, so that first term would be 3/5. If n is 2, then it's 3/5 squared, and that's going to be 3/5 cubed, and then the fourth term is 3/5 to the fourth. Now, I don't know if the presentation of the choices would be written like this. If they're not, know that you can square this fraction, and 3/5 squared becomes 9 over 25. And then here, 3 cubed is 27, and 5 cubed is 125. And then use your calculator to assist you in finding this fraction if that's the presentation of the choices. All right, 82 and 83. Find the common difference. So when we read those words, that should tell us, oh, these are arithmetic sequences, because common difference is associated, that terminology is associated with arithmetic sequences. Okay, and it does go on to say for the arithmetic sequence. So what are we adding every time to produce the next number? Well, by inspection, I know that's 4. That sum is, or that adding, that common difference is 4, and then to go from 15 to 19, that's 4. The more technical way is to take 2 consecutive terms and take the second term of the 2 and subtract the previous term. So 11 minus 7 is 4. 15 minus 11 is 4. Moving on to the next set of consecutive terms, 19 minus 5 is 4. So to find the common difference, this common difference is 4. Okay. 83, it looks like I'm adding 5 to generate all the later terms in the sequence, the arithmetic sequence, so that common difference is 5. Okay. All right, let's look at the next group. Okay, so we're finding the sum of the first n terms of the arithmetic sequence. Okay, so there is not a formula given for this, and we are not allowed to have formula sheets or notes. So I might suggest to you that you might want to kind of commit that formula to memory, the sum of the first n terms of an arithmetic sequence. Ooh, okay. Yeah, because especially in 84 and 85, you can see that we're going to be summing 41 terms and 42 terms. So you really want to know that formula, that sum formula. It's not a big issue in 86 and 87 because you're only adding 5 terms here and adding 3 terms here. And with 5 and 3, it'd be easy to generate those 5 terms and add them together in your calculator, and generate these 3 terms and add those together in your calculator. Not so much with 84 and 85, unless you wanted to persevere. Okay, so here's the formula that you should probably commit to memory then. So the formula for the sum of the first n terms of an arithmetic sequence is the fraction n divided by 2 times the sum of the first term and then that nth term. So in example 84, I want to find the first term and I want to find the 41st term. Okay, well, that might not be too bad. So let's see if we can kind of deconstruct and decompose this. So for 84, n is the number of terms I'm adding, 41, not bad. So I got 41. A sub 1 is what I need to find. Well, plug in 1 for I. So 4 times 1 is 4, 4 plus 2. So the first term is 6. And now a sub n is, again, 41. So we've got to find the 41st term. So 4 times 41 is 164, plus 2 more is 166. Actually, not too bad at all. So now let's insert everything in our formula. So the sum of the first 41 terms is equal to 41 over 2 times 6 plus 1, 66. Of course, we're going to go straight to our calculator. And looks like we're going to get 3526. At least that's what I got. Okay, not too bad. Okay, so let's look at this one right here. Then the sum of 42 terms. So I'm going to come over here and spell out what we have. We have n equals 42. We need that. And then we need the first term, a sub 1. Well, let's plug 1 in here. So that would be 3 minus 4, negative 1. And let's plug in a sub 42 is what we need. So 3 times 42, 126, right, 126, yes, minus 4, 122. Oh, what am I doing? Goes here, 122. Right, this was getting ready for the sum. So the sum is 42 divided by 2, and then let's add negative 1 plus 122. And I got 2541. Okay, for 86, like I said, if you can't remember that formula and this number right here, this n value is manageable, I mean, you could actually just generate the 5 terms. This isn't bad at all, and then just go back and add them up on your calculator. Same thing here. You could just generate 3 terms and then add those all up on your calculator. But let me see. I'll just go ahead and use this formula again. So the sum of 5 terms. Okay, so that's going to be 5 divided by 2. So when a is 1, I'm going to get 3. When I is 1, I'm going to get 3. And when I is 5, I'm going to get 11. So I think if I added first and got 14, then 2 goes into 14 7 times. 7 times 5 is 35. Or just go to your calculator. Whew, okay. This is the third partial sum. So this is 3 halves. All right, let's plug 1 in for I. So that would be 1 whole minus a third. We'll change 1 whole to 3/3, and you're going to get 2/3. All right, now let's plug in 3. So 3 goes in here. So 1/3 times 3 is just 1. 1/3 times 3 is 1. Yeah, 1 minus 1 is 0. So the third term would be 0. All right, and then just multiplying. Well, we're multiplying fractions, so let's divide these out. Divide these out. Looks like I'm going to get 1. So that sum is 1. Okay, so yeah, the takeaway is I'd probably want to try and commit that sum formula to memory unless it's a more manageable n value, and you can just expand 5 terms and add them, expand 3 terms and add them, and you will end up with the same values even if you use the formula. Okay. All right, last two, 88 and 89. If the given sequence is a geometric sequence, find the common ratio. Okay, so that means if we have a geometric sequence, we're always multiplying by the same number to produce the next term in the sequence. So, I mean, by inspection, you can see that to go from 3 to 12, I'd have to multiply, not add. That's arithmetic. Geometric is multiply. I'd have to multiply 3 times 4 to get to 12. Well, do I multiply 4 by 12 and get 48? Is 48 by 4 192? Is 192 times 4 768? Yeah, we can think about it that way. The more mathematical or technical way is choose 2 consecutive terms and take the later term and divide it by the previous term, get 4. 48 divided by 12 is also 4. Okay, and this next set, 192 divided by 48 is also 4. So the common ratio is 4. All right, 89. Looking at inspecting the terms of that sequence, I can see that the numerators don't change. However, the denominators are changing. So I'm trying to do an inspection here, see if this is geometric. How do I go from 2 to 8 and 8 to 32 and Is it the same as going from 32 to this number? I think it's by 4s. But I would just do a couple of quick divisions. Is 8 divided by 2, 4? Yes. Is 32 divided by 8, 4? Yes. Is 128 divided by 32, 4? Well, the calculator will tell you it is. So the common ratio is not 4. The common ratio is 1/4. Because to go from this 3 to this 3 to this 3 to this 3, I'm always multiplying by 1. So the common ratio for this problem is 1/4. And we made it.